Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank
I
you.
will just do some changes in this topology. So what I will do, I will just create one more router over here in order to understand the dynamic routing. And the first router which we are going to see, RIP, which is actually a distance vector router, and we will do certain practicals on that. Okay, so I will connect the switch. Okay, this switch is also connected. I will take only one computer over here. Don't require to do any more. Okay, so I will turn it off. I will add to this. Okay, so this is done. I will connect the wires now. So I will take the wire from here to here, here to here, here to here. Okay, here I'm using 192.168 this network. Here I'm using 100.1 network. Okay, and here I'm using for Ethernet side 192.168. I will go for 172. 172.18.0.1. So I would be using the network ID 172.18.0.0. Okay, it's a complete class B. I'm going to use 172.18.0.100 is the IP address of this computer. Correct. Now we will use the same topology for every routing protocol. The one which we are going to see, the first protocol called as RIP, and RIP stand for Router Information Protocol, which is a complete open source protocol. And we will see how RIP actually needs to be configured, what are the different features for that, and how we are going to configure it. Correct. So this is a type of routing information. You can keep it ahead. Now, out of that, we are going to see the first category called as distance vector protocol. And under this, we do have a category called as RIP. That is called as Router Information Protocol version 2. Okay, there is version 1 also. And we are talking about version 2 also. Correct? To understand what are the different features which we have with this particular distance vector. Correct? Now this is first of all open source. That means it is not a proprietary product. It is available for everyone. Every router provider can put their RIP information or RIP routing logic or that particular algorithm which is free of cost. Correct? This is a classful routing protocol. Okay. Now I'm talking about version 1 is actually classful. In version 2, classless is actually available. Means classless is supported. Correct. After that, you can see in version 1. Okay, I'm talking about version 1 first of all. Let's say V1. the metrics in order to find out the best path. Okay, in RIP version, the metrics in order to find the best path from source to the distance would be hop count. So you can say metrics would be hop count. Okay, we will see what the hop count is. Now updates are done in a broadcasting fashion. Means whatever they are going to send the update with each other. So that update would be done in a broadcast IP. That means it would be 255.255. Okay. Now load balancing of 4 equal path. Okay, I will tell you this also load. Okay, this is the 5th point. Load balancing, okay, of 4 equal path. Okay. So maximum hop count over here. Now it worked on hop count. So max hop count would be 15. Okay. So the number of router which we can use it for, you can say 16 router. I will tell you this, what is the logic and how the calculations happen. So max routers would be 16. Okay, it's 60. Okay, then exchange updating would be happen every 30 seconds. Okay, and AD distance would be 120. Okay, so these are few features about RIP version 1. We'll discuss about version 2 also because there are few additional support they are giving. Okay, the first thing is it's a open source. That open source means it's a complete open technology that multiple vendors do have RIP version into that. So there is no compatibility with any other version you want to go with. Correct? After that, classful. Now in version 1, once again, the problem with the classless would be, correct? Sorry, classful would be, I cannot transport the subnet mask along with that updating information. That's a problem. So if I cannot send you any subnet information, then you are not supposed to work on that particular subnet, or you can say that you cannot work on that particular part. Correct? So here my particular router won't be able to send the subnet information to other router. So I can only send the best route, but that best route only contain IP information, does not contain the subnet information. So by default, whatever IP information it should become as a classful information. So my router would be able to actually understand properly. If I use it for classless, that means if I do receive the bunch of the IP address, but whatever IP address which I received as a best route from others, and if it is subnetted, then it is a problematic, because my protocol think that is a classful, but it is actually what? It is a classless. So if any kind of such situation is also happened, okay, in RIP, so in RIP version 1, it is only support as a classful IP addresses. Matrix would be hop count. Hop count means how many routers you required in order to go to the destination. So if I say this is my source, this is my destination, okay, and if I do have multiple routers of that particular thing, then he will consider that how many routers are required in order to reach to the destination. Correct? This is also very important. Okay, this is called as hop count. Okay, now after that, update the broadcast. That means he is sending the updated routing information or routing information in a broadcasting fashion. He is not doing any kind of a multicast or unicast. So he is actually doing the broadcast. Correct? This is something where your bandwidth could be hampered because your own router is sending his information across the network with the help of internet. So there is problem. Load balancing with 4 equal paths. Now let's take this condition. Let's take this scenario. So if I say this is my source and this is my destination, and this is the only one router, so this is the minimum count is only one router, so I said this is my best path because I just need to cross only one router. But imagine I do have 4 different routes which is actually need to cross only one router, so all 4 are my best route because I just need to cross only one router. Then I do have a hop count of 2, this and this router, so minimum hop count is required. So if I get something like this, that would be my best route regarding RIP, because my metrics would be what? Hop count, how many hops are required. Correct? And if I'm getting the minimum hop count, then that would be my best route for this. Now in this case, if I have a multiple best route where I would be able to get particular router destination, this is only one, correct? But if I'm getting such best route like this, then by default up to 4 equal paths, that means up to 4 equal cost, that particular best routers, my RIP do the load balancing between them. So they will do load balancing for equal cost of the path. That means if I have 4 different routes with only one router, then rather choosing one, I will take the advantage of 4 and do the load balancing between that. But it condition would be load balancing up to 4 equal path. This is very important. Correct? Updating would be happen every 30 seconds. Correct? Update, that means that router is sending the routing information across the network every 30 seconds. He is doing broadcast. This is again a problem because in RIP he is sending all the routing table information with each other. It is happening in a broadcasting fashion and every 30 seconds he is doing that. Correct? This is problem because lot of the network bandwidth is actually occupied by router itself, because he himself sending lot of routing information for every 30 seconds across your network. This is where your bandwidth can get utilized. Correct? So you can see it is a open sourced product, version 1 I'm talking about. It only work with a class full, that means it does not support any kind of subnetted networks at all, because my router, when they are exchanging the information, they are actually not passing the subnet information with each other. Correct? So this is very important. After that, maximum, the metrics in order to choose the best path is called as hop count. Minimum number of hop count is there in RIP version 2, then that would be my best route in order to reach to my destination. Correct? Load balancing for 4 equal path. If I find out there are 4 different equal path are there, that means I do find out 4 different path which are my best route, then I will do the load balancing with that.
Hey viewers, our Master in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So, what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Correct? Updating 30 seconds. That means update which is happening in a broadcasting fashion, plus he is updating every information with each other. Now that activity would be happened for every 30 seconds. And max hop count is 15. Okay, that means whatever number of routers which RIP can support, which is nothing but 15. Like this is one of the loophole, or you can say this is one of the drawback of your RIP protocol. Correct? Now, what is a hop count? Now, my particular RIP version 1 or even version 2, correct? It will go up to 15 router only. Correct? So if I do have 15 routers connected serially, 1, 2, 3, up to 15. Okay. Okay. This is my source router up to 15th router. Correct. Then only my RIP works. If I got any 16th router, my RIP will not work. It drops it. It drops the connection. This is a limitation for RIP version 1 protocol. Correct? So understand, this is very important. RIP is a distance vector. Yes, it is a distance vector. No problem with that. It work on hop count. How he's going to choose the best path? He's going to choose the best path with the help of the mechanism called as hop count. Hop count means how many routers I need to cross in order to reach to destination. That is, minimum number of hop count would be my best route. Correct? Then update are broadcasted. Agree. Update are sending every 30 seconds. And what update they are sending? The full router table information. Does not support any subnetting because it does not provide any subnet information while updating each other. Correct? So these are few information and very important information that it will only support up to 15 hop count. Okay, 15 hop count means he will not include himself. He will exclude himself, and from that 15 hop counts are actually he supported. That means total 16 router, including himself. If I include himself, it would be total 16 router up to which your RIP version 1 works. Correct? And his AD distance is 120. I will come back to this AD distance. What is an administrative distance is. Correct? So I will talk about that particular thing, but every routing protocol do have a specific default administrative distance. Correct? So this is RIP version 1, which is a distance vector routing protocol. Correct? Now there is one more protocol they have introduced called as RIP version 2. Now this is some better version. RIP version 2. Okay. Now rest of the things means your hop count is same. It will also support 15 hop count. The maximum hop count which RIP version 2 also support 15. Correct. But there are slight changes which they have done. RIP version 2 support classless. That means subnetted information, if it is available, he can share that. Correct. Second important information, they have done it in RIP version 2, support authentication. Now, while they are exchanging the information, sometimes you will set up some password across the router while updating that particular information with each other, correct? For security reason. Now, in RIP version 1, there is no such facility. But in RIP version 2, they can provide the password to routers. If you have the unique password and identical password between the routers, then only you are able to exchange the information and process that information. Correct? And very important thing, he will send the update not in a broadcast fashion. He will send the update to the multicast fashion with this IP address 224.0.0. Correct. This is the multicast IP address for RIP version 2. Correct. Now there is one more RIP version is there, that is called as RIP NG. Okay. We will see tomorrow what is RIP NG once we understand IP version 6. RIP version NG stand for next generation RIP protocol. It is the same. Rest of the things are same. The only thing is that it works on IP version 6. Okay. Rest of the features are same kind of metrics he is going to refer it, same kind of uh, options are available, that it will also support the max count, AD distance is 120, update is happening 30-second multicast fashion, correct? But it works on version 6 IP addressing, correct? That is the 128-bit IP addressing which you have. It works on that, correct? So this is very interesting RIP. So this is a all category would becomes under the distance vector. Now IGRP is also distance vector protocol, but IGRP was Cisco proprietary protocol which we are currently not using anymore. We are not using that particular protocol at all. Now let's see how we are going to configure RIP protocol, and we are trying to go for version 2. Correct? Now let's see. First we will configure all the interfaces. Now look, whenever you are doing practicals, do step by step. Okay. So we will first of all configure some IP addresses over here. I will say 20.0.0.1, and this side should be 20.0.0.2, correct? Because currently I cannot emulate the internet connection. So for this serial interface, I need to choose one network and they should be able to communicate with each other, correct? So what we will do first, we will take this router first, we will set the interface IP address and we will configure the computer IP address, correct? So let's go ahead. Now it is connected to the serial interface 020. This is the port it is connected to. And what is the gigabyte? Gigabyte 0/0. So you can see if I pull down this is gigabyte 0/0 and serial number 020. So first set this IP address to this serial interface, set this ETH interface of a local side to your gigabyte interface of the router. I said okay. Serial is already configured. I come down over here. I said no. I will say enable interface serial 020 IP address 20.0.0.2. Okay. Subnet mask would be 255.0.0.0. I said no shut. Correct. I will exit interface gigabyte 0/0 IP address 172.18.0.1 255.255.0.0. This is a class B. No shut. Done. I just want to set up the IP address on the computer. It should be 172.18.0.100. This is a subnet mask. What is a default gateway? This interface IP address which is belong to router. This would be the default gateway. If I do not have a default gateway, I cannot go outside the network. Your request will think that you are the part of their local network. So I configured the IP addresses. What I will do over here, I will save this setting. I will save this setting. I will say copy running configuration to startup configuration, because the same setup I would like to use for some other routing protocol. So I'm going to save it. Correct. So this router configuration has saved. Okay. Now go to this router. Now I'm only saving the configuration for IP address of the interfaces. Okay. I have not configured any routing for this setup at all. I will go to the command prompt. I will say enable conft. Correct. Then I will say interface serial 031. Correct. The IP address would be 20.0.0.1. Subnet mask would be this. I will say no shut. Okay. So I configure this side of the interface. Let's configure this side of the interface. It is 030. So I would say exit interface serial 030. Okay. I will say IP address 10.0.0.2 255.0.0.0. Enter. I would say no shut. Correct. This is the gigabyte Ethernet IP address. We would like to say that also. It is connected to the gigabyte 0/0, and this is the IP address. So I would say exit interface gigabyte 0/0. IP address is IP address 192.168.100.1 255.255.255.0. Okay, enter. I will say no shit. Okay, that's great. I will save this configuration permanently. Okay, I would say copy running configuration to startup configuration. Done. Correct. So this is also done. So I'm just creating the IP addressing on the interface only, and I'm saving that. So I just next time I will configure the router information with RIP, but I will not save it. I just power cycle it. All the RIP information would be wiped out, but whatever I saved it, it would be a permanent information. So let's go to the first router. Go to the command line. Okay. Now 100% this is also gigabyte interface. Okay, this is serial 030. This is the IP address, and giga 01. Okay, so enable conft. Okay, interface serial 030. IP address 10.0.0.1 255.0.0.0. Enter. Exit. interface gigabyte 0/0 IP address 192.168.1.1 255.255.255.0. Correct. I would say no shut. Forget to put the no shut on a serial port. Okay. Exit. Okay.
Hey viewers, trying to get into DevSecOps? Enroll for our DevSecOps certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Say no shut. Okay, so I just configured all the IP address. So next time I will say copy running config. Okay. Okay. Do W also can do the same thing. Okay, that is also building and writing the configuration from your config mode. Okay, so I configured all the IP addresses and I have saved it. So we would like to configure RIP version 2. Correct. Now RIP version 2, which we are going to configure on this particular router, and we will see what are the different things which he can do it. Correct. So what we can do it, I will go to this router first. Okay. Now what networks which I am connected over here? This, correct? I will simply confirm it. I will say show IP interface brief to check whether it's configured correctly. Gigabyte, okay. It's properly configured. Now I would like to configure RIP routing on this particular router. Okay, look at here what I'm doing. I will say router. Now I do have an option called as RIP. I said RIP, correct? Press enter. Now I will say the command called as version. The version would be 2, correct? Then what I'm doing, I'm telling network. Which network I do have it? I do have this network, correct? 192.168.1.0 network, correct? What else I have network connected with? I have this network is also connected with me. That is a 10.0.0.0. Press enter. Correct. So whatever connected to me, that is the only information which I am providing to RIP. Correct. So if I say currently, I will go here. I will say show IP route. Okay. Currently, you will not be able to see anything. You would be able to see only 10 network. Okay. You can see only the network which is a 10 because it is already attached over here directly, and only the network called as 1.0 which is also directly attached. Correct. He won't be able to see any of other routing information at all. Correct. Let's go to the middle router. Now middle router contain how many network? He contain this network, he contain this network, he contain this network. I don't know anything about this, correct? I don't know anything about this, that's fine. But what you know about yourself, that I need to provide, correct? So I would first of all check show IP interface brief. I will check what are the IP address are properly configured or not. Yes, it is configured. I will go conf t. I will say router RIP. Okay, press enter. Then I will say it is version 2. That is also fine, no problem. Then I will say network. Which network I do have? 192.168.100.0 network. Okay. After that, which network do I have? 10.0.0.0. Okay. 20.0.0.0. Correct. I would exit out of it. Exit out of it. And I will say show IP root. Now you can see what happened. Now you can see I am having my information. I am having the 20 information and also having the information about this network. Okay, I come to know that this network I am connected via. Now how this particular router will come to know about this network? I have not informed anything. Even if I go here and now type IP root, I am able to find out the information about this network. Why? Because whenever RIP, the moment RIP is configured over here, they started exchanging the information about their routing tables with each other. I was not aware about 20. I'm talking about this router. I don't have any connection with 20, but this router currently know that if I would like to go to the this network, I should go via serial this interface. This is the interface which you should go out. Correct? Now let's go here and configure your. I will say show IP interface brief. Okay, both the IP address is configured properly. Now I will say conf t. I will say router RIP. I will say version 2. Okay, I would say network 20.0.0.0, which I know about it. I would say network 172.18.0.0. Correct. Now, if I say exit to IP root. Okay. Now you can see now all the information are exchanged. This router contained all the information about 10, 20, 172.18, 192.1, whatever information they required, he knows about it. That means my routing is successfully configured. RIP started sharing their best route with each other right now. Currently, this is RIP version 2. That means multicasting is happening. I'm sending the update in a multicasting fashion every 30 seconds. The multicast IP address is 224.0.0.9, correct? And I am currently able to ping the connection, correct? So if I go to this computer, I will check my own IP address first. It is 1.0. Now let's try to ping 192.168.100.100. Okay, destination host unreachable. Now what is the problem? So let's go to this computer. Desktop. Okay, it is there. Okay, set. Then why it is going here and it is coming back? Let me see whether the root is available over here for 172.18. Show IP root. Okay, 172.18 root is available, so it should go here. No problem. 172.18.0.1. Okay, Then where is the mistake? Do show IP interface brief. 99% it is a problem with IP configuration. 172.18.0.2, 170.18.1.0.2, that's fine. It is configured, both are up, no problem. Then why this computer unable to communicate over here? Okay, let's find out. I will say press RT. Press RT. Oh, I type 166. That's the problem. Okay, it's 168. That's the problem. Okay, so it's a typo mistake. Everything is configured properly. So it should be, yes, you can see it's working fine. So my RIP is configured properly. Correct. So whatever things which are required, my RIP is now currently working in this entire network. Clear? So what is a distance vector router and how RIP is actually going to place this particular role? Is that clear to all of you? Or any questions regarding RIP or distance vector router? It is very simple. RIP or any dynamic router, only he talk about the information about himself. Correct? Rest of the information he will get by exchanging the information about that. Correct? So I will give you one topology, and if you could do that particular topology, that would be great. Okay. Now I will help you that particular topology to understand your administrative distance as well. So I will give you one topology to configure RIP. So we'll do something like this. Okay. Okay. Now look at this topology. I'm just connecting in this format. Okay, just give me a moment. Okay, now if I configure RIP in this particular topology or in this particular environment, correct? What would be the best route which I can use? Can anybody tell me if I configure RIP as a routing protocol, what would be the best route which router can choose in order to go for source to destination? Anyone would like to try that? Router 20. Now, good. Now, why router 20? Because the router RIP will always go with the minimum hop count. Now, from source to destination, I have only one router. The least number of hop count, I would be able to choose that particular path. If this particular router goes down due to some any reason, I will choose this path. If this goes down, I will choose this path. If this particular thing will come up, then once again my best route would be this one. Correct? If I have such best route like this would be also one hop count. Okay, this would be also one hop count. Correct? This would be also my one hop count over there. Then what will happen? If I have 4 different paths or more than that, correct? What would be the option which we can use it? What would be happened if I do have 4 different equal hop count? What RIP can do? Anyone knows about it? We just discussed that particular point. If you do have equal path or the cost of that path, yes, load balancing, but it will do the load balancing up to 4 equal path. If you got fifth one, he will not do the load balancing with the fifth one. The maximum load balancing would be happen with 4 equal cost path. Correct? That's great. Okay, that's great. Shushmita and Chaitra, absolutely fine. So this is called as RIP. Very simple, very effective in certain small networks, but the problem is he will go up to 15 hop count only. That means total 16 routers only, not more than that. Correct? So if your network is in between maximum 10 to 15 routers, if you have it, you can use RIP without any problem. But if you are having a more network than that, then it is problematic for you. Correct? So understand, RIP work for some small network, but people, to be honest, not using this network nowadays because their networks are beyond their limits. Now there is one more concept regarding the RIP which you should know, that is called as RIP timers. There are timer mechanisms.
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Okay. Now we know that there is a by default update timer is there. Which is 30 seconds. Okay. Now my particular router is actually sending 30 seconds. Every 30 seconds he is sending a multicast message to the group of that particular routers where RIP is configured, and he will check whether is there any update available in the routing table or not. Correct? If I missed any router, that means any of the router is goes down. If say this router is goes down, okay, and I will send him some update, but he's not responded. Okay, then there is another timer called as invalid timer. Invalid timer is in total 180 seconds. That means your previous 30 second plus 150 second more. So he's saying that I sent some update information, but he's not responding for me. Actually, he's not responding. Maybe that router is turned off, I don't know. But I send the request this is my update, please give me your update. Correct? But he's not responded. So there is a concept called as invalid timer. Router will wait for 180 seconds in total, including your first history, and he will say invalid. Okay, inside the routing table, he will make that entry invalid. But remember that he is not flushed that entry from the routing table. He simply say invalid. We will try that, no problem. Okay, that particular router is invalid. That means that particular best path is invalid. Okay, after that we do have a third timer called as flush timer. Flush timer means after total 140 seconds, means whatever previous 180 plus 60 more seconds. So previous 180 seconds means your update and invalid timer plus more 60 seconds. After that, he will flush that particular information for that particular routing table. So you can see certain time he will make sure that if maybe that till 180 second that particular link can come up, maybe some technical difficulties. Correct. And after that, he can able to get that particular information within that 240 second. He will flush that entry from that. Now there is also a concept called as hold on timer. Now that is also 180 second. Now that particular thing would be happen only for first time. Whenever first time I turn on my particular router, my router will require 180 second to gather the information from other neighbors. Correct? So what we can do, we will turn this particular link off. Okay, this particular link, we will turn it off, shut down, we will list, and we will see after certain time your entry would be flushed from this particular routing table. Currently, if I go enable show routing route show IP route, currently that entry is available, 20 entry. Correct. I will shut down this link and see whether I am able to see the entries for 172.18.0.1. Correct. So I will go to this serial configure terminal interface serial 0/2/0. I believe that is the interface which we are going to talk about. Yes, that interface. I will say shutdown. Okay. Now that link is shut down. Now we would like to check it is happened. That link is shut down. So we would like to make sure that that entry which is belong to this network 172.18, okay, it should be removed from this IP route. It is gone. Okay, it is gone from that list. Yes, it is gone. Now if I make that interface turn it back on, okay, now wait for some time. Now that entry should come up. Okay, you can see that entry would be picked up. Correct. So this is RIP timer. So there is some timers are available in RIP, and based on that particular timer, you would be able to remove that entry, make the invalid entry from the routing table, so nobody can use that particular path if it is invalid. Correct. So this concept is called as RIP timers. Correct. Now we talked about AD, so I will close this all the windows, so that will save. Okay, now we talked about this AD120. Okay, now I told you that AD stand for administrative distance, and we need to understand what is a administrative distance. Okay, this is very important in order to configure the router. If you would like to proceed in CCNP or CCIE, these basic concept, it's very vital in that particular type of exam. Now the concept is called as administrative distance. Okay, administrative distance is, you can say, it's a trustworthiness of information received by the router. Okay, I will write it down. It's called as trustworthiness of information provided or received by the router. Okay, and less value trusted. Correct? Now it's a very important mechanism. Now let's take this example. Okay, now let's say this is my source and this is my destination. Correct? Now my all these routers will provide my different best route to reach to my destination. This router is providing some information. Okay, sorry, you can see this router is providing, okay, your path is this. These routers are providing your best path is this. Your routing is also provided this best path is this. Correct? Now, what is our main purpose? To find out the best possible path in order to reach to the destination. Correct? Now, administrative distance says that it will help you to create a trust factor between the router which is providing the information. For example, this router is saying to this router, you know what, you should go to this particular route, that would be the best route. But how do I trust on this particular router whether he's providing the right information or wrong? What is the trustworthiness on this particular router whether these are the best route? Correct? Now I need to trust what information which you are providing to me. Now that trust can be handled with the help of the concept called as administrative distance. Correct? How could I believe that these routers are updating me and saying me, okay, you know what, this is the best route. But how do I trust you? Correct? I should have some mechanism to trust on you. Whatever information which you are providing to me, it is the right, I can trust that information on. Correct? Now, in order to increase that, we have a mechanism called as administrative distance. This is a trustworthiness of the information received by the router. Now, let's understand how it is going to work and what are the parameters for that and what AD is equal to 120 means. Now, to be honest, on a single router, either you can use only single routing protocol to communicate with everything. Okay, that means I want to communicate with this, I want to communicate with this, I want to communicate with this. Okay, majorly we try to make sure that you should use only routing protocol. Okay, in production. Now, in order to understand administrative distance, I can say something like this. I configured RIP protocol for this network. On this router, I configured RIP for this part. Okay, this is RIP. Okay. Then the middle path which you have, it is a static. Just assume that I configure the static with the help of IP route. Okay. And after that, the last path is configured by EIGRP. Now, EIGRP, we will see after this, it is a enhanced interior router gateway protocol. This is the routing. So technically speaking, this kind of scenario won't be happen on a single router. But to understand administrative distance, we can have three different type of routings are configured on my router. Correct? Now you can see by default, there are some standard administrative distance numbers are given based on your routing protocol. For example, if I'm using RIP, my administrative distance is 120. This is a standard value. Okay, you cannot do the changes into top of it. Correct? If you configure static value, static routing, the administrative distance is 1. If I configured EIGRP, the value is 90. If I configure OSPF, that is again a routing protocol, the value is called as 110. And if I'm directly connected, the interface is directly connected, then it is 0. Correct? Now you can see these are the standard values. Now if I go back to our topology, what is happening if I configure something like this and to understand the administrative distance? RIP will send the update through this link and send it to this router. You know what? You want to reach this? This is my best route. Now, while providing that information, he is also providing the RIP administrative value is 120. Okay, we know that RIP do have a standard value, and he is telling me that my path which I am giving you, it is the best one. Agree? He is also sending me the information. This is a static. He's saying that no, he is actually not right. Whatever I'm information which I'm giving you, that is the best path. Now EIGRP is also a protocol. He is also sending you the information. You know what? This is the good path for you in order to reach to this destination. Now for single destination, I am supposed to get three different options now. Now which one would be trustworthy? To whom I should trust that whatever he is selling me, it's right, and I can take his information and put it in my routing table. Correct? Now the confusion will be solved by this. If you are having the less trusted value, okay, the less trusted value would be accepted by router. Now in this case, he will accept the static route to be the best route in order to reply for that destination. Why? Because my trustworthiness is more, because I'm having the left trust value. Correct? So this is the function of administrating distance. Is that clear to you? Any doubt in this?
Thanks for watching. Want to study further? Join our training programs today.